Hello and welcome. My name is Barbara Krumay. I'm a professor at the Johannes Kepler University Linz and happy to present the research results. The paper we're presenting here is entitled Readability of Privacy Policies, a study which has been conducted together with my former student, Jenny Klar. First, let me guide you through our agenda. I'd like to start with a short introduction and motivation, followed by some related research and describing our research design. We will present some results and conclude with a discussion and conclusion. So what is the role of privacy policies and why do companies engage in improving readability of privacy policies? Privacy policies or privacy statements are an instrument for communication with customers. In particular, on websites of companies, B2C, business to customer companies, you will find privacy statements explaining which data is collected and what is done with it. So readability and comprehensibility of privacy statements influences relationship with customers. As the customers understand what is done with their data, their relationship and the trust in the company may increase. To improve readability and comprehensibility, some regulations like the GDPR, the General Data Protection Regulation, require a clear language in the privacy statements for the customers. So what is the motivation for this research? Companies need to measure or are looking for a possibility to measure readability of their privacy statements. There are some measurement methods, but they are rarely used for privacy policies. Qualitative approach to measure readability are hard to automate. This means that they are time consuming. So what is necessary is identifying an easy to apply yet valid and reliable measurement method. So the aim of this research is to suggesting an approach to measure readability of privacy policies. I'd like to give a short overview on related research. First, what is privacy? Privacy is the claim of individuals, groups, and institutions to determine for themselves when, how, and to what extent information about them is communicated to others. This is important to realize that it is a right of the individual, a right on privacy. And privacy policies mainly describe legal, technical, and social issues. Legal issues, for example, related to how the data is stored and how it can be transferred to other third-party organizations. Technical issues, cookie handling, for example. And social issues. What does it mean when we collect your data? What do we do with your data? In these privacy policies, specific terms are used, and these specific terms, legal terms, technical terms, are often hard to understand for non-experts. When it comes to readability, a definition of readability is it is the sum total of all those elements within a given piece of printed material that affects the success that a group of readers have with it. The measurement of readability in general is based on the complexity of text expressed in grade levels. So the complexity of text depends on the length of the text, the syllables, the words, the sentences used, how long they are, how long sentences are, how many sentences, words, and syllables are in the text, and in addition, vagueness or negativity expressions influence how well a text can be read and understood. There are some existing approaches allowing automation, yet they are rarely applied to privacy statements. We selected companies operating in Europe as the GDPR, the General Data Protection Regulation, mainly affects companies doing business in Europe. To set a baseline, we analyzed the text parts based on qualitative parameters such as simple language, paragraph organization, avoidance of redundant information spread in the text, as well as highlighting important information, which is necessary to improve readability. In addition, we assessed organization and structure, Based on a coding sheet, 2 researchers independently analyzed the texts, but compared and discussed the results after having finished their analysis. We calculated intercoder and intracoder reliability based on the Holsti idea, resulting in a score of 0.97 and 0.95 for the intracoder reliability and 0.81 for the intercoder reliability. For analyzing the text, we used MaxQDA. We analyzed the text in a semi-automated way to count text length, sentences, words, syllables, and characters based on the according rules related to the measurement approaches we have selected. In addition, MaxQDA supported us in identifying negativity speech, negativity rating, and vagueness. In addition, we developed specific stop lists related to privacy policies or privacy statements. For example, company names and email addresses were not coded and were not used for the further analysis. As we aim at suggesting an approach to measure readability of privacy policies, we start with existing approaches measuring readability. We have selected 7 existing approaches to measure readability: the Dale Call Index, the Automated Readability Index, the Gunning-Fogg Index Readability Formula, the Smog Grading, the Fry-Graph Readability Formula, the Flash-Kincaid Grade Level, and the Coleman-Liao Index. You can look up more information in our paper. We have selected those based on the variables, so to say text length, word count, and so on, they consider for calculating the readability or expressing the readability, and most of these scales express readability in terms of grade levels. You also see some abbreviations here. We will see the abbreviations in our results tables again. We applied these 7 selected measurement approaches on a sample of privacy statements. We selected 15 companies from the Forbes list. We focused on companies which have at least some B2C context. This means that they address end consumers with their websites and their privacy statements. This is due to the fact that B2B, business-to-business companies have different privacy statements and different legal conditions. We did not investigate or analyze the whole privacy statement due to different reasons, not only the text length, but also the different language used in different parts, like legal or social or technical, but we're looking on the part explaining cookie handling. This is the part where we have, of course, a lot of technical wordings, but on the other hand, it is in most of the privacy statements we have looked up. And in addition, it is easy to identify the scope of this part of the privacy statement. As a result, we came up with a table of quantifiable parameters of the sample text. As you can see here in this table, we have on the left side our companies, our sample companies, and we have the different variables used in the approaches, like the word count, the sentence count, the average sentence length in words, the average syllables per word, the average characters per word, negativity rating, vagueness, and qualification. Regarding word count, we identified 4 privacy statements or the parts explaining the cookie handling with a very high word count from the BMW Group, Gazprom, Siemens, and Nestle. So these 4 parts explaining cookie handling had the most words. Second, we analyzed sentence count. And again, the same 4 privacy statements or sample text where they had the highest sentence count. Next, we analyzed average sentence length. And it's not very surprising. However, we see that those who have high word count and high sentence counts, of course, have a relatively low average ratio regarding average sentence length in words. So we identified 4 texts in our samples, three, Banco Santander, BNP Paribas, and Sberbank with a relatively high average sentence length. What we can see very clearly is that the text from Banco Santander has a rather high average sentence length compared to the other texts in our sample. Interestingly, the average syllables per word and the average characters per word were not very different in all the texts. The only thing we might identify is that the average characters per word in the text from Siemens was the highest. Regarding negativity rating, which means no, not, none, the text from BMW and Gazprom had rather high rates, 1.37% of the overall text and 1.25% of the overall text. When it comes to vagueness and qualification, we see that other texts have here a high percentage, like the Allianz Group, Banco Santander again, and Gazprom. We will further elaborate on this on our next slide. In the next step, we applied the measurement methods to the text, which means the identified variables and the according numbers were used to calculate the grade levels. What you see here are the different 6 approaches to measure readability. We do not report on the Dale call index as the results were not conclusive, probably biased by the Dale's list of familiar words, which is a precondition to calculate the Dale call index. And we do not report on the FRE, which is part of the FKGL. In general, considering all results, the sample seems to require at least grade 10. So people who should read this text or should be able to understand this text should have at least grade 10. As we can see, the Coleman-Liao index CLI and the Flash-Kincaid grade level FKGL are often slightly lower compared to other scores. However, some scores are not in line. For example, the CLI related to the text from Banco Santander is pretty much average, whereas the other scores, ARI, FOG, SMOG, FKGL, are rather high. And so is the average of all scores for this text. This is interesting since the text from Banco Santander has already been identified as one with the longest average sentence length and the lowest number of sentences. The scores from the text from Daimler, interestingly, are rather low, all scores below 12. Another low average score has been calculated from the scores for the cookie policy of Daimler. However, the fog is above 12. When you look at our table here, you can see that there is an additional column on the very right part of the table, which is the experience. The experience of 15 consumers we exposed the sample to. So we exposed the sample to 15 consumers to gain more insights for the interpretation of the results. The text with the highest average score, Banco Santander, here it is, with 17.75, was experienced by all participants, by all consumers, as very complex, hard to understand, and long. Other text with high average scores is the text of BNP Paribas, the text of Siemens, and of course the text of Gazprom. Of course, I'm saying because it was the text which was hardest to read from the experience of our customers. What was particularly interesting in this text, the text from Gazprom, was that the text was experienced as holding many unfamiliar words. When we selected our consumers we exposed the text to, we first tested how fast they can read, and we have seen that in our sample, or the consumers we used for evaluate the results, we had fast readers, which means they can read 1,500 words in 5 minutes, and slow readers need 12 minutes per 1,500 words, are in all grade levels. So in general, text experienced by all participants as very easy or easy to read, here the abbreviation is ETR, showed average scores below 12. By contrast, the text experienced as hard to read, HTR, by all participants showed average scores above 14. The text parts from Daimler and Volkswagen were assessed as being very easy to read by all our participants. Let me shortly summarize what are the results of the evaluation by the 15 consumers. The text with the highest average score, 17.75 Banco Santander, is experienced as the longest, most complex and hard to understand, although it is not the longest text. But due to this complexity, people even experience the text as being very long. The text with most unusual words was the text from Gazprom. There were many technical terms, but not only the technical terms were the problem. There were unusual words which could be replaced by easier to understand words, or words which are used more often. Fast readers, 5 minutes per 1,000 words, and slow readers, 12 minutes per 1,500 words, were on all grade levels. So when we selected the sample, we made sure that we have all grade levels, and the grade levels, in the grade levels we have fast and slow readers. The reading speed had no influence on the experience or the assessment of the text. When we relate the results to grade levels of the consumers in our sample, this showed the expected results. So the grade levels they had were matching the grade levels related to the text. This is a sign that at least these measurement approaches do what they aim to do. They give a score, more or less, related to the grade level. Not all the scales provide a score. The text from Daimler and Volkswagen were assessed as being very easy to read by all the participants. This is interesting because only Daimler and Volkswagen directly addressed consumers with their text. So let's discuss the results and come to a conclusion or a suggestion. The readability of privacy statements is currently rarely measured. This is due to complex ways of measuring readability, qualitative existing approaches which are hard to automate, and due to the privacy statements using a specific language, have a specific length. The existing approaches share some similarities. They relate to the complexity of the text and grade levels, yet differ in their details, the variables and length of text used. Comparing the approaches shows that different variables, like syllables, seen as not reliable by some researchers, are producing similar results. What do we suggest, as our aim was suggesting an approach to measure readability of privacy policies? We suggest combining approaches. in particular the fog, smog, and CLI, and enrich them by qualitative variables, vagueness and weighted negativity rating. We have done some combinations of the three approaches and the vagueness and the weighted negativity rating and came to a pretty stable result. Comparing different versions of privacy statements to identify the one with the best readability score seems to be one scenario we would suggest. So have different versions of a privacy statement, apply the combined scores and enrich by vagueness and weighted negativity rating, and use the one which is having the better rating. This means the lower score, because we want to have it, the readability increases the lower the score is. The other way would be to permanently rewriting and measuring privacy policies until the readability formulas generate a certain grade level. Let's assume grade level 10 is what we aim for, or grade level 8 is what we aim for. Both approaches can be done in an automated way. We can use natural language processing approaches, or we can use the scores, of course, or a combination of both to improve readability of privacy statements. So thank you for listening. Looking forward to talk to you in the session.